So today I'd like to talk about this problem. It's a greedy problem, and greedy problems tend to be more interviews friendly, as they tend to test your ability to think and find a solution and take the right decision to come up with the optimal solution instead of just memorizing algorithms or patterns or something like that that exists in other problem types. And also greedy problems tend to be easier to understand the problem statement. They are short in description, as we see here. So we are just given a number, okay, and we want to maximize the value of this number by performing only one swap. So given this integer, we would swap the 2 with the 7 to make it the bigger integer, okay? And we are required to return the maximum possible value performing only one swap. And we also can perform no swaps at all. So something like that, we just return it because it's already maximized, and this as well. So swapping this 9 with the 0 would minimize the integer, which is not the intended behavior we are aiming for. So back at this example, we need to have a greedy mentality to solve this question. So starting from this digit 2, we will scan the whole left array, and obviously we are going to turn that into an array to easily iterate through it. So let's quickly do that. So we are going to use less comprehension in Python, and as simple as that, okay? So starting from each digit, we are going to scan the whole array to find the biggest possible digit to swap it with 2. And in a greedy manner as well, we will iterate from the right end of the array, okay? So let's say we have a 7 here. Swapping the 7 with this 2 won't give us the maximum number. Instead, we should use this 7, okay? Because this holds a higher rank from the 7. And initially, we started from the left of the array to greedily consider the highest digit regarding the rank, okay? And the same way, if we have 9 here, we would take it over the 7. So apparently we would have 2 nested for loops, okay, going from each digit and scanning the whole left portion of the array. But in order to reduce the time complexity to O of n, we would do some pre-computations to hold the most right position of each digit. So for 9 we would have this position, and for 7 we would have this position instead of this one. We don't care about this one anymore. And this is also a greedy approach. We don't care no more about any left 7s. We only care about the rightmost digit of each number, okay? So let's quickly construct this positions array. So it would have a default value of -1, indicating that we don't have this digit. So we don't have 4 here, so it would stay -1. And we would have a position for each number. So positions of 4 would equal -1, indicating that we don't have 4. And for 3, it would be 2. And that's for all the 10 digits we have, okay? So quickly we are going to enumerate and the digits and make the positions of n equals I, resulting in an array that holds the most position of each digit. And after that, we are going to perform our greedy algorithm we discussed. So for each digit and the digits again, we are going to have a nested for loop, which is basically iterating from the end of this array. So we would start from 9 and we would end at n. And this is actually an interesting part. So let's say we are at 6, we don't need to check for any digit that is less than 6, so we don't need 3 or 2, okay? And that's because of, let's say we have 3 here, we don't care about that, okay? So once we check for 9, 8 and 7, we don't care anymore, okay? So after that we would skip 6 and try with the next position. And if we ever finish the whole array and we never find the value, that would mean we are considering this edge case, so we just return the given number, okay? And at each step we are going to go down by one step. So if the position of the current digit is does not equal -1, meaning that there exists this number in the remaining part of the array, and at the same time this position does not equal the I, so that would prevent us from swapping the element with itself, okay? Actually, we may not need that, okay? So the position is bigger than I, so we may be at 3 here, and we consider the 7. We don't want to swap that because it would minimize our integer, okay? So this condition is for that. If this is true, we just swap it. So positions, this should also be positions, and this as well. So swapping the positions of I and the digits actually. So digits of I and digits of positions of J. We would swap that with J, and digits of I, okay? And after that we return we would convert this to a string digits in order to join them and turning them into an integer again to return it, okay? So yeah, it's an O(n) solution with an O(n) space complexity because this position array is fixed. And this for loop actually has a worst case of O(n) because once we find solution we return it immediately, and this for loop is constant. We are just performing 10 iterations, and this even might be constant because the length of the number array could be a maximum of 8, so this would perform 8 iterations at maximum, and this 10 iterations at maximum, so 8 times 10 would be 80 iterations, but let's say just an O(n) solution. Thank you, that's it.